So we're moving to rate of change. Rate of change is what? What does the word rate of change mean?
Growth, decrease or increase.
So it's either increasing or decreasing. It's how fast it changes, right? It's how fast things change. So the rate is how quickly at which something is changing. So sometimes we refer to it as ROC, just for shortcut instead of writing rate of change. It's ROC, ROC. So the ROC is often indicated by the slope of a graph. Okay? So a slope is basically another word for rate of change. Okay? Slope, rate of change, steepness, they mean the same thing. We usually use either the word slope or the word rate of change. So when I'm finding the slope or the rate of change, I have to look at the slope. And the slope is the rise versus the run. Okay? So if you look at this graph right here, right at this line, the slope of this line is the rise versus the run of the graph. So I look at 2 points, I indicate 2 points on the graph, and I look at how much does it rise by versus how much does it run by, and that's my slope. Okay? So there's 2 ways that you can find the slope or the ROC, and that is either by looking at a graph and doing rise over run, or by looking at the 2 points, finding the x and y value of these 2 points. And then by subtracting using the formula y2 minus y1 over x2 minus x1. Okay, so you look at the 2 points. Remember, each point is xy, right? So this point right here is x1, y1, and the point B is x2, y2, right? The values of them. And then what you do to find the slope, you do y2 minus y1 over x2 minus x1, which is going to end up being the same thing as rise over. Let's look at this. So the question is asking us to calculate the average rate of change between each pair of points. Explain what the rate of change means. So if I look at this, I have time and airplane height. Time is my x, and the airplane height is my y. Yes? So that's going to be x1, y1, x2, y2. What's the formula for the slope or the rate of change? y2 minus y1 over x2 minus x1. So it's as simple as y2 is 1400, so you write 1400, minus y1 is 2000, divide by x2 is 4, minus x1 is 0. Okay? So, first thing is I named, I indicated what these points x and y are, and then I put them into the formula. Okay? Remember that x goes first, y goes second. So that's going to be negative 600 over 4. Which is negative 150. Now here's the difference between slope and rate of change. Can I have your attention for a second? So if you've taken the grade 10 when we talk about slope, we never use units, right? Slope is just y2 minus y1 over x2 minus x1. We don't mention units. When we're talking about rate of change, we have to include units. That's the difference between rate of change and slope, is that rate of change have a unit. So if you're looking at this, the y value, what is the unit for the y's?
Meters.
Meters. And then what's the unit for the x?
Minutes.
Minutes. So that means your slope is going to be meters per minute. Do you guys agree with that? Right? Because I'm dividing y over x. So that's meter over minutes. So if you're looking at this slope, negative 150 meter per minute, we're talking about an airplane, an altitude of an airplane. What can you tell me about that? How can you explain that negative 150 meter per minute?
Decreasing.
It's decreasing, it's going down, descending 150 meter per minute. This is exactly what it means. Okay? So the height of the plane is decreasing. Are you guys okay with that? So this is another graph, and this one is for the vehicle rental cost. I have the rental cost on the y-axis, and I have the distance driven on the x-axis. Again, I'm trying to find the slope, or the the rate of change. So the formula is so looking at the 2 points, I have x1, y1, and then x2, y2. So this is y2, so I'm going to start with 700 minus 400 over 400 minus 200. Okay, so I did 700 minus 400, and then for the x values, 400 minus 200. So that should be 300 over 200, which is 3 over 2, or 1.5. What would be the unit for this? Dollars per kilometer. So that means you're going to be paying $1.50 per kilometer.
So in these cases, should we write 1.5?
Yeah, that's fine, because it's money. And you're not going to say 3 halves. So cost increases by $1.50. And this is increases because it's positive, right? Does it make sense? And it's increasing by $1.50 per kilometer. Are we good? The distance required to stop a car depends on the speed at which the car is traveled. Use the tables below showing the reaction distance and braking distance needed to stop a car on dry pavement for a given speed to answer the following. Calculate the average rate of change between consecutive points in each table. Describe the rate of change revealed in each table. So what do you see here? You see the speed of the car versus the reaction distance. So how long does it, like if you're moving at 10 kilometers per hour, you need 2 meters to stop. Okay? If you're moving at 20 kilometers per hour, you need 4 meters to stop. So this is basically what this relationship is. Okay? So if I want to find the rate of change, what do? I want to find the rate of change of these 2 points. What do I do? Huh? Subtract what?
Speed from reaction.
So I have
We
to
have to
subtract
from
this
speed.
minus this. Remember, it's y2 minus y1 over x2 minus x1, right? This is my x's, this is my y's. So 2 minus 0 over 10 minus 0, right? y2 minus 1 over x2 minus x1. Are we okay with that? So it's going to be 2 over 10, which is 0.2. Now, what would be the rate of change between this point and this point? Over, which is 2 over 10, that's 0.2. Then I have to do it between these 2 points. 6 minus 4 over 30 minus 10, which is 2.
So why are those in relation to the formula? Why is x, the x's 10, 20, 30, 40, 50? How are those x1, x2, and so forth? Because I'm not sure how you came to 20 versus minus 10.
Because I'm taking 2 points at a time.
Yeah.
At first, I took these 2 points.
Yeah.
Then for the second one, I took these 2 points. Then I took these 2 points. Okay? So you can't do, you have to only pick 2 points. And then you're going to name this y2, y1, x2, x1. Then when you take these 2 points, then the 4 is going to be your y2, and your 2 is going to be your y1. x2, x1. So you're looking at 2 points at a time. Make sense?
Okay, so let's go on. Okay, so let's continue.
What would be your next one?
8 minus 6, 40 minus 30.
That's right. Because now I'm looking at these 2 points. Right? So it's 8 minus 6 over 40 minus 30. Which is 0.2. And the last one is going to be 10 minus 8 over 50 minus 40, which is 0.2. So, what can you tell me about the rate of change for all of these, between all of these points? It's constant, right? The rate of change is constant. That means if I'm going to graph this, I'm going to get a line, right? Because remember when we talked about it earlier, when we had a line, a straight line like this, right? We said the rate of change is constant. We said that it's always changing in the same. Remember Jack's earning, right? He's always earning $14 an hour, right? The rate of change here is also constant, right? That means it's going to be a linear function. So what am I going to write here? So constant rate of change. So reaction distance increases kilometer, 0.2 meters. Per. So what I want you to do for the next one is I want you to do the same thing. So you're gonna find the rate of change between all the points and then you're gonna write them down.